cleaning up some tabs real quick. Stabilizer. What is this? Oh, okay. All right. So back to where we were. Record transactions. Now, going back to what we were talking about yesterday, having data archive the mutation side, send data as fast as possible to Iggy, and at the same time store data. But the Iggy streaming side should not be limited or held back in any way by the storage side. So this side should be able to stream data, and data should be saved as TIKV is also being saved. And so these databases should be getting updated at the same time or before, I don't care, as TIKV is being updated. So this stream here, I think that this stream, basically taking this, having a Tokyo task that consumes this stream as fast as possible and sends it into another stream. So we end up having some task that gets started here. I wonder. Let's call a function fork call stream. We'll send that. We'll get back some other channel. Right? So we get a stream back. Have this. This stream here, this type can change. At this point, it could be NPSC, unbounded receiver of that, or just an unbounded receiver. Okay. Oh, not that. Okay. Come back a little bit. So I know we can fix that setup. Let's go ahead and fix that setup real quick. Receive. Oh, this should be. That's strange. Because it's an option. Remove that. Expect with context. Now we're not unwrapping it twice. Oops. Expected none error found status. Oh, because our stream closed snafu specific. Good. And then here, same thing. Mm. That's more correct. Okay. Okay. So we have request stream. That looks like that's set up just fine. A couple small changes. This seems more accurate for stream request. Okay. That's interesting. We have a future here, and while it's wrong, let's see, import that from Tokyo. Channel. There we go. About a channel. I want something similar to that, but not yet. Some message return an option. All right. Hmm. Wonder if we should have something else. Maybe this should be a result to a transaction chunk. That way we can forward on any sort of error that we get from message, and it can still be responded or still be returned in the request pipeline. Ooh, maybe. Yeah, let's play with that. Tonic status. Okay, here we want to transpose this to now chunk result. Mismatch types, yes. Oh, I put that on the wrong thing, didn't I? This here is not that. Morning, McCullard. How are you? And thank you for the bits. Happy Thursday. I think we still want this. So I want to put this back. Whoa. Why did it do it there? Right here. Let's fix this again. Put this back. Stream closed. Oh, needs drop. Yes. Did you see that in here? Because um, sometimes sometimes things like a channel, you might need to drop it to close the channel. Oh, on the right side. Um, my code it says size 4 and line 16 bytes and needs drop. So if I hover on something, right? Um, for example, if we come back here, batch for a moment, trying to find something simple. Yeah, I think that was part of the documentation actually. Here, right? So this chunk result here. So when I hover over this item, this just means that the compiler will go through the process of dropping it. Right? So the destructor, if you will be called on this item. I think if we had something like a yeah, this guy here, the TX and RX, their drop functions will be called when they are no longer in scope. Yeah, if that's yeah, you're welcome. I'm gonna pour some hot water here. Five full, 3/4, and we're done. All right. It's just 100. Correct answer is 107. So, type mismatch. What do we have here? Yeah, okay, so and on this, let's undo. So now we've got this. Oh, where is it? I'm zipping around too much. Oh, the moderation clip that shared demicode. Transpose is amazingly useful. It is really useful. Oh, museum. So yesterday I went and looked at the source for the Mozilla, was it Atomics Triumph, and it looks like they're also doing the same sort of thing in terms of allocating. Um, so when you take and move a vector into arc to be a arc of, let's say, a slice of U8s, it looks as though you still copy even with Triumph. Too bad replication. Well, thank you, McCullard. I appreciate it. But I did have some fun looking at Triumph. I was curious as to the difference between it and the one in standard. So, yeah, DB state. No, where's that? Nothing here. Fork and stream request. Actually, I think I want two of these. Graph has better support for DSTs and treating the arc as a thin pointer. Interesting. So it can be used in C++ to match the semantics of shared pointer. Oh, vector of t slice is basically u size a fat pointer. Okay, but an arc doesn't represent memory like that. Hmm. It's close. If we have that or the other error, there we go. Essentially, it boils down to the size of and layout of the arc not being the same as box, which doesn't need reallocation, even though a vector doesn't contain a box slice internally. The DST represents is compatible. Oh, I see. Huh, that's cool. This also there's oh interesting. There are solved issues from what happens with C++'s shared pointer, which is sometimes atomic and not atomic all the time. Rust makes it fully atomic. If you want non-atomic, use RC. Right, right. Huh. Oh, that's cool. Okay. So stream 2 we are going to send to Iggy. Stream chunks to Iggy, stream 2. I wonder but the reallocation isn't too expensive. Let's see. What isn't too expensive, and LLVM should optimize it out. That's interesting. Either alias the pointer or move it. Got it. And one other thing I was curious about, now that you bring up these things that LLVM aliases out, um, in Rust, is it still true that memory moves onto the stack first and then gets copied into the heap instead of being copied straight onto the heap? I remember something a while ago about that. It's generally calc and memcopy and debug mode. Okay, got it. But LLVM can optimize it out. Huh. wonder if we should wait on this here. We should have a join handle. Is it worth telling others that we couldn't stream it? Interesting. But in general, yes, it's static allocated and then moved. Placement new. Ah, that's what it is. Yes, placement new. It's a concept in both C++ and Rust. With Rust, it was originally tried with the, whoa, the left arrow operator. Then with box keyword, the box operator was removed. Huh. If I come in here, what I want. I don't think so. As long as it's making it to the database itself, and we record transaction, I think we're okay. If we fail to stream it to Iggy for some reason, let's say Iggy crashes, I want it here. And if GIKV crashes, we want to tell the source about it. Okay. It's sort of done in standard via the box attribute. I'm not familiar with the box attribute. Like box new, which is standard, say for. Huh. Okay. Oh, it's forever unstable and internal. Okay, that's fine. All right, let's go ahead and generate this. Looks about right. I don't have any plans on returning anything yet. They'll probably make it automatic when local allocators are ready. Oh, what do you mean local allocator? Oh, I see. Yes, the new in functions. Got it. That's local user. Okay. Yeah. And that's a big push to get those done for use in like Linux, right? We receive the error. We're going to ignore it because the error is really for the other side. Linux only needs failable allocations. That makes sense. They're fine with a global allocator, but handling out of memory is important to the kernel, yes. A C box now. To show us Rust only forever. I do find it interesting that there are different flavors of Rust. Right? There's the Rust C flavor. There's the nightly flavor, right? A stable flavor. And then there's the GCC flavor, which tastes an awful lot like the uh, stable flavor, but without all the compiler errors and whatnot. Oh, interesting. Transition function for the next bootstrap bump. Huh. This is interesting. Issue. I like that, being able to associate these with the actual issues. That's nice. That's and having it part of the language, right? For unstable. Yeah, that's pretty neat. There's a lot of foresight there. It's almost as if they had, built compilers before, and yeah, it's very GitHub first. It's one of the most active projects on GitHub. We ignore this. So we ignore the whole thing. Okay. No, I like it better this way. Okay. Yeah. How do we stream a chunk to Iggy? But it also comes from Mozilla culture. Ah, yes, where Bugzilla issues are all over the code. I also hear that some of the. So I have a friend that used to work on the um, garbage collector. And the what is the name of? Is it Spider Monkey? Um, yeah, he was saying that there's debug assertions all over the code base. So when you mention issues being linked all over the code base, that just reminded me of it. That's kind of a same with Rust C. Interesting. Just funny, like, wait, when I look at just open source projects, and maybe if I looked at Servo, I would see the same thing, but I tend not to see the same sort of um, plethora of assertions. Rusty's debug asserts also produce bug reports for ICE breakers. Interesting. Wow. Let's call this stream. Oh, that's right. We also need Shift F12. From self, we need a copy of stream, raw stream. We need that. Self to stream.clone, yes. And what is this thing? Archive streamer. Fun. Of course, TriageBot and Boris. I'm familiar with Boris, but not TriageBot. Manage the sheer amount of traffic in the repo. MDBook was also written for the compiler to produce books on how to work on the compiler. Wow. We want this stream database transaction too. No, not that. Where's the other ones? I feel like I'm missing some. Didn't I add like two other functions to this? It's basically the opposites of these. Oh, it's on raw streams? Oh. XTX. Okay, this is the interface that splits between Iggy and Piggy. These here, okay. Every click you make. Okay. Okay. So I need some other interface. I need to be able to set this at a high level. Okay. I don't want to use raw streams directly here. Voice was written for monotone, green things before Rust, and then updated for Bors and G. Huh. I had never heard of a monotone. Then there's a new Bors in the works. Oh, they're written in Python. It's a version control system. I have to click a little bit on the other computer. The Linus hated C++. The monotone was too complex, so he wrote Git. Oh, wow. Huh. Oh, I see. Git is heavily inspired by monotone. Wow. He made Rust because he didn't like the C++ and monotone. Oh, I love it. So it's fancy that Rust uses GitHub and Bors, which were inspired related to its parent history, right? Full circle or something. And now Git is getting some parts of it written in Rust. Oh, a new transaction ID. UN64. Based on wall log frame header checks. for the first page of the transaction. Really? Okay. I wish I had created a type for that instead of just stuffing it into an N64. Yeah. Placement new and specialization and variadic generics are your top 3 wanted Rust features. it's placement news could happen. It's been tried like 4 times before. Oh wow. I feel like we've almost got this tunnel connected from both sides. We're coming down to the last few bits. Okay. I I want this to be something more interesting, its own type. Final containing commit record. Yes, yes. Database page. What's in there? Page number, the checksum, and the raw data. Okay. Commit record. Page count checksum. I think we changed these recently. Wish I could right click and get the references to this. As for Rusty and GitHub, let's see. In the past month, just on the master branch, excluding merges, 173 authors have published over 1,000 commits to master and over 1,000 commits to all branches. Wow, on master, 52,000, almost 53,000 files have changed. And there have been nearly 4 million additions and 30,000 deletions. That's a lot of additions. Wow. That is insanely active. I wonder if GitHub has certain repos on like in different clusters, right? So like the Rust C one is on like an extra large repo or cluster. That's pretty cool. Yeah. Oh, okay. Let's see. Lordira, thank you for the follow. And good morning. Happy Thursday. So, what is this transaction ID? No idea. Normally, I would have commented what this is actually made of. Now, data line. Receiving side, DB. Transaction ID. There's no transaction ID there. Yep, that's right. The WAL is the write ahead log. That's correct. Well, let's take a look at the placement new bits. Copy link address. So you pass in the allocator. I see. New in. That's pretty cool. I've only ever used this once. Huh. Where did I use it? I didn't use it like this. It was a maybe on a net. Yeah, I used this. Okay, which is slightly different. It'll track the flow to the rest of the box stuff and make it do it in place. Wow. Oh, they are. Okay. So the new internet in is a new internet of self of a box, and then you write to the box. Oh, okay. Gotcha. That makes sense. Okay. It's cool. Okay. Before I sign off today, I want to figure out what this index is. or the transaction ID. So mod db. So this is the receiving side, which I believe is where we are. Lots of different errors. Database sync. Oh, this is a long file. Okay, database sync. We want sync databases. Sync databases calls attempted download. Listen for database changes. Listen for database changes has a connection. Stream database updates. Relative path, starting checksum. Great. Connection stream database updates. Open the file. Task, here we go. DB transaction. Okay, good. Same thing. Write DB transaction. Or page in that. Where are we using the transaction ID? Nowhere. Context. Yes, these are test helpers. Replicate. Yeah, replicate I know uses it. Keys. Line. DB changes. This is on the mutation side of the house. That's surprising. It just seems like this is not used. Let's see. So the new in is still a work in progress. Currently it moves it from the stack to the allocation, but the goal is to make the compiler smarter about it and place it directly. And Black Caddis, thank you for the follow. First, the world has to be structured differently. So a graph can be built to a known root. Polymorphic resources in C++. Okay. Which will you use multiple allocators at the same time for the same type. Oh, interesting. Some of the data is in this allocation, some in that one. Wow. They being sensible people. Yeah. It seems like using new in, you could have a type that has data in different allocators. Did Mrs. Halsey come with a full set of requirements and acceptance tests for me to comply with before development started? No. Nope. Standard web dev applies. Yeah. Luckily, there was no timeline either. So, yeah, you can make an allocator that contains two allocators. Yeah. It seems like the composable route is the correct answer. Yeah, standard customer. That's right, Torque. Well, because this is not used, I guess we could just send what we have through. I'm not sure that I like that though. Let's see. Here we have transaction ID. I mean, it does have the salts in it, but the comment here is that transaction the value is based on wall log frame header checksums for the first page in the. And that I don't understand. Maybe it's because of the tests. All right, let's look. F12. What is this file? This is KB checksum as U64. That seems weird. This one. Transaction ID is a server database checksum. It feels like I just never implemented this portion. My copies are bump allocated and heap allocations go to the normal system. Oh, but in C++ you could have the copy constructor use one allocator, yes. The normal new constructor use another. Oh, that's interesting. Yeah, that makes sense. Okay. Yeah, that would be confusing to use. Hmm. I am so surprised that this here is done this way. Change server transactions. It also feels like I could change this pretty easily and nothing would care. Let's explore that idea. Does everything compile? Target test. No, it doesn't. Okay. Oh yes, this. Thank you. That should panic that. All Rust standard types that do heap allocations have had an A allocator generic param forever. The new stuff just lets you override that A as call time rather than a type site. Hmm. Okay. See, we've only made changes to this today. So I'm going to change everything. Actually, okay, let's close that. Data proto, we'll keep over there. These, close. Okay. Some good changes in here today. Streams forked. Oh, there is one thing I want to see. I can't avoid this allocation, can I? If I toss this into an arc, it's going to copy it and clone it anyways. Well, copy the data. Except, wait, string doesn't let you override the allocator? Huh. Yeah. What is transaction chunk? Transaction chunk here has a couple strings. Same thing we were looking at, I think, the other day, where we have this vector of database pages where the pages are, they have bytes. Interesting. Bytes is somewhat magical. So it feels like it's not worth actually tossing it into an arc because it ends up being copied once anyways. Oh, we were looking at the a diff here. That's right. For here. Yeah. I think I'm only ever going to have these two. If I have one, the other one is cheaper. I don't think I would because I can't guarantee that one will outlive the other. Um, oh, but I see what you're saying. But the channel could be more efficient. Interesting. The size of arc would be 24 rather than 138. Yeah. Oh, that's interesting. Yeah, 104 here. Plus the okay. Hmm. So now, okay, so that's where like kind of CPU time. But in terms of like memory pressure, if I use the arc, then I only have one copy of the pages floating around, which is actually kind of nice. It basically halves the amount of memory that has to be in flight. I like the idea of making this here use an arc instead because of memory pressure. Okay, let's change that. A channel is essentially a vec_t. Got it. Here. It means 4/5 smaller. But then I also have, because it's not just, it's the size of the pages, right? And there could be 40 kilobytes of page data on the heap. It's also the size of the result. Yes, yes, it is. So really, it's this. Okay. Get that. Now the types here should be arc as well. What is this? Chunk result in this case is arctos result. If we match on that, oh, interesting. It wouldn't arc the result itself, but rather just the okay part of it. Okay. No, that makes sense. That makes a lot of sense. Yeah. Let's move these in. Chunk result. So yes, in this case, map arc from, like you were saying earlier. Okay. Let's adjust these again. Result, arc, fork stream. Back to that one. Transp. That's why. I was wondering why everything was highlighted. Okay. For page and chunk pages. In this case, we have a reference to a database page. Hmm. Can set database page work with a reference? Could we change that to use a slice? Raw storage put into value. It's going to copy it here. I guess we just push the allocation down the stream a little ways. But our overall memory would be less, because in this case, we would just be copying per page. Ah, the time. I must run. And actually, we're wrong. Oh, okay. All right. Arc on a composite type struct. Don't do a deep clone. It'll just clone the stack data. So the vex don't get reallocated. Oh, interesting. Oh, well, that's nice. Okay. Got it. Got it. Okay. But I do have a meeting I have to run to. I appreciate the correction there. We're going to raid and run. So the arc's always cheaper. Oh, lovely. Just kind of picking someone at random. Thank you all for hanging out. I got to run. Oh, there I go. Okay. Take care.